Hi, Assalamualaikum. We are from D1 CSC126 and we are going to present our group project, which is Cloudrunner Airlines e-ticketing system. Before that, let me introduce my group members. Our group consists 4 members, which is me, Siti Nur Izzah binti Ghazali, Afifah Najihah binti Muhammad Zaki, Nur Aizatul Azwin binti Roslan, and Raja Muhammad Khairul Hazim bin Raja Shamsul. For table of contents consists 5 of it. First is project summary, second is project objectives, third is analysis, fourth is design algorithm, and last but not least is demo of the C++ program. So, here is the project summary of ours. This project presents a console-based flight ticket booking system developed in C++, designed for international airports across Asia. Users can input their personal details, select a destination from 9 major Asian cities such as Singapore, Indonesia, Thailand, Philippines, Vietnam, Laos, Cambodia, Myanmar and Brunei. Choose their seat class, which is economy, business or first, and specify the number of tickets to purchase. The system will calculate the total cost including an 8% tax, generates a payment receipt, and issues personalized e-tickets. This project also uses sequential, selection and repetition control structures, along with functions and arrays to ensure a structured and efficient flow.
Now, let's talk about the objective for this project. The first objective is to record the flight ticket bookings made by the customer through the system. Second, it is to calculate the total amount to be paid. Third, it is to find the most popular destination. Fourth, it is to generate a digital receipt and e-ticket. Now, I'm gonna talk about the analysis, input, process and output for this project. First, I'm gonna talk about the input. First, it asks for passenger information, which is name, destination, seat type, flight date, ticket quantity, and payment confirmation. Second, about the process. First, it check valid destination code, seat type, and flight code. Second, it track number of booking per destination. Third, it calculate price by multiplying ticket price with seat price and adds up 8% of tax. Next, it generate e-ticket by how many quantity the user wants. And then lastly, it determine the most popular destination. Next, about the output. The first output should be the display destination menu. It shows a table of all destinations with seat price for the user to choose. And then it displays flight schedule, which displays available flight for the selected date. And then it displays receipt, which shows ticket price, quantity, subtotal, tax and total amount. And lastly, it displays e-ticket, which print formatted ticket with passenger details and flight information.
Now, I'm going to explain the flow of a flight ticket booking system using pseudocode. This system helps users choose seat types, enter booking details and make payments. At the start of the program, we can see multiple variables being declared. Name, date, flight, time, seat type and desk name are declared as strings to store user-entered text. Desk, quantity and flight code are integers to hold numerical values. Type is a char to store a single letter for seat type. Price per ticket and tax rate are floats for value with decimal like price and tax. Booking count 1 to 9 is an array used to keep track of how many bookings are made for each destination. First loop is a boolean value initialized as true, which might be used to format the program display only on the first run. After variable setup, the program displays the title and sets the tax rate to 8%. First of all, the startup and user input. It then enters a repeat loop, asking the user to enter their name, then call the function destination menu to show available destinations, and ask the user to enter the destination code. If the entered destination code is not between 1 and 9, the system shows invalid destination code and skips to the next iteration. Next, seat type input. The user is asked to select a seat type. E for economy, B for business, F for first class. If the user enters something else, the program displays invalid seat types and restarts the booking process. Valid inputs are converted into proper text format like economy or business. Next, booking and flight details. Once the seat type is valid, the system increments the booking count for the selected destination. Calls function get booking details to get the date, flight number and time. If the flight is marked as invalid, the program skips that booking and starts over. After that, ticket pricing and receipt. The user is asked to enter how many tickets they want. Then, the program gets the destination name using function destination dash. It calculates the price per ticket using the destination and seat type, and calls function generate receipt to show the full cost including tax. If the payment is not confirmed, the system shows booking cancelled and skips to the next loop. And then ticket generation and loop. If payment is confirmed, the system calls function generate ticket using all the booking details: name, seat type, flight, date, destination and time. After that, the user is asked if they want to make another booking. If they enter Y, the loop repeats. If they enter N, the loop stops. Lastly, show most popular destination. At the end of the program, the function show popular destination is called to display the destination with the most booking. So, this pseudocode gives a full plan for handling flight bookings, from getting user input to generate tickets, calculating prices, confirm payments, and looping until the user exits.
Okay, now we're going to walk through a practical example of an e-ticketing system in action, specifically the Cloudrunner Airlines e-ticketing system. This slide illustrates a complete booking process from a user's perspective, showcasing both the input and the corresponding system output. Let's start by imagining our user, Siti Zulaika, initiating a new flight booking. The system efficiently displays a list of available destinations along with the corresponding seat prices across different classes: economy, business, and first class. As you can see from the example on the left, each destination is assigned a unique code. Siti decides to select destination code 2, which is Indonesia, an option for business class ticket. Next, she input her desired flight date, which is 3 February 2026. The system then dynamically presents the available flight for the specific date, showing details like flight code, flight number, and departure time. Siti then select flight code 3 CR08, departing at 8:30 PM. After selecting her flight, Siti specifies that she wants to purchase 2 tickets. The system immediately processes this information and calculate the payment. For a business class ticket to Indonesia, the price per ticket is Rm500. So, for 2 tickets, the subtotal is 1,000. Crucially, the system also calculates an 8% tax. This brings the total payment to Rm1080. Finally, a comprehensive receipt with a full payment breakdown is displayed, ensuring transparency for the user. Now, we continue to the next slide. After the payment calculation, the system prompts the user to confirm the transaction. This next slide shows the final step of the booking process, from payment confirmation to the issuance of the e-ticket and a session summary. Our user, Siti Zulaika, confirmed her payment by simply entering Y for yes. Immediately, the system springs into action, generating 2 distinct e-tickets. As you can see on the left side of the slide, each e-ticket clearly displays all the essential details: the passenger's name, Siti Zulaika, the flight number CR08, the flight date 3 February 2026, the seat type business, and the trip detail Kuala Lumpur to Indonesia, along with the boarding time of 8:30 p.m. These digital tickets are now ready for use. Once the e-tickets are generated, the system intelligently asks Siti if she wishes to make another booking. In this scenario, Siti decides she's done for now and enter and for now, which gratefully conclude her session. Before exiting, the system provides a concise summary highlighting key statistics. In this particular instance, it shows that Indonesia is the most popular destination with one booking, reflecting Siti's recent purchase. This final sequence demonstrates the system's ability to not only process transactions efficiently but also to provide clear confirmation and a helpful summary closing the loop on the user experience. It's a testament to the system's comprehensive design, ensuring a smooth and information journey for every user. Thank you.